Let's look at a few more implicit differentiation type questions. So for number 5, we have if f of x plus x squared times f of x to the third equals 10, and f of 1 equals 2, find f prime of 1. So this one's a little bit tricky, but we can figure it out. And the first thing that we have to recognize is that f of x is just another way of writing y. So for our equation right here, it looks kind of confusing, but what it's really saying is y plus x squared y cubed equals 10. And when we look at it as y plus x squared y cubed equals 10, it's not as scary looking as when we look at it with the f of x notation. So we're going to consider it this way. So this question is asking us to take the derivative because we need the derivative right here. So we need to use implicit differentiation because we can't solve this for y equals. So the derivative of y is y prime. The derivative of x squared y to the third, we need to use our product rule. So that's going to look like the first times the derivative of the second, which will be 3y squared y prime, plus the second, which is y to the third, times the derivative of the first, which is 2x. So we have our first times the derivative of the second, plus the second times the derivative of the first. And then the derivative of 10, 10's a constant, so that's just 0. So we need to find our y primes. They're right here and right here. We need to put them on the same side of the equals, and everything else, all of the terms that do not have a y prime, need to move to the other side. So it looks like I need to subtract this 2xy to the third from right here. It needs to subtract to the other side. Now we can pull our y prime to the front, and we can factor it out. So that'll look like y prime pulled from here will be 1, and then plus 3x squared y squared. Equalings, we still have our negative 2xy to the third. All right, now we can do our division. So that means y prime is going to equal negative 2x y to the third over 1 plus 3x squared y squared. Now in this one, we're given a little bit of information. And what we're given some information for is that when x is 1, see right here? This means when x is 1, then y is 2. So we're trying to find the derivative. What this means is find the derivative when x equals 1. So that means we can take our values for x and y and we can substitute them in, and that will give us the derivative when x is 1 because we're using the x value of 1. So that's going to look like, right here, it's going to change over to negative 2 times 1 times 2 to the third all over 1 plus 3 times x is 1, so 1 to the second, and y is 2, 2 to the second. And now we need to simplify this down. So if we try to simplify this down, well, we put in all of our values, so we just need to simplify. So in the numerator, well, 2 to the third is 8. 8 times 2 is 16, so negative 16. Negative 2 times 2 to the third, negative 16. And then what do we get in the bottom? Let's see here. We have 1 squared, that doesn't change anything. 2 squared is 4. 4 times 3 is 12, plus 1 is 13. So it looks like we get negative 16 over 13. And that is the value of our derivative, in this case, when x is 1 for this equation. So let's try the next one. Use implicit differentiation to find an equation of the tangent line to the curve at a point. Okay, we can do this. So let's start with our implicit differentiation. We got another little mini product rule right there, x and y. So first and second. So the derivative of x squared is going to be 2x. Bring down your power, subtract 1. So the derivative of x squared is 2x. Plus, got to use our product rule. First is x times the derivative of the second, plus the second times the derivative of the first. The derivative of, oops, we missed a piece. Let's put that one in. We have this plus y squared right here. So plus the derivative of y squared is 2y. Bring down your power, subtract 1. And then don't forget you're looking at the derivative of y. And then we have the derivative of 3 is 0. So find your terms that have your y prime in them, put them on the left, move everything else to the right. So this one's going to need to be subtracted, this one's going to need to be subtracted, and then we'll leave our xy prime and our 2y prime on the left. So that looks like it's going to give us xy prime plus 2y prime equals, we need to subtract 2x from both sides, and we need to subtract y from both sides. All right, we're making progress. We have our y prime right here and right here. So we need to factor that to the front. So y prime. And then we have x plus 2y. That's equaling negative 2x minus y. So if we divide both sides by our x plus 2y, because that's what's being multiplied by the y prime, we get y prime equals negative 2x minus y all over x plus 2y. Now this one is asking us to find the equation of the tangent line. So that means the derivative is going to give us the slope. We have a point right here. We have 1, 1. So we need to figure out our slope, and we're going to get our slope from our derivative. So we need to substitute in our x values. So we know x equals 1 and we know y equals 1 because that's what we're told from our point. So that means that y prime is going to become negative 2 times 1 minus 1 all over 1 plus 2 times 1. And if we simplify that down, we have negative 2 minus 1. That's going to give us negative 3. And then in the denominator, 1 plus 2, that's going to give us 3. So that means our slope is going to be negative 1. So now we have a slope, we have a point. So we can use our y minus y1 equals m times x minus x1 equation. So y minus 1 equals negative 1 from our slope times x minus 1 right here. So then distributing through, y minus 1 equals negative x plus 1. Add 1 to both sides. It looks like we're going to get y equals negative x plus 2. So now we have written the equation of the tangent line to the curve, and we've used our implicit differentiation to take our derivative so that we could write the equation of our tangent line to the curve at the specified point.